And here we go. We are live. This is our first Planetarium Live here for Astronomy in Action. We're calling it, well, I'm calling it Planetarium Live because it's, oh, there we go. Let's make it visible. I'm still new to this whole streaming thing, so it's going to be a little bit, oh, there we go. All right, let's start this again. Welcome to Astronomy in Action's Planetarium Live. This is my first time doing a live stream. It's a little bit weird being a planetarium guy without a planetarium to actually enjoy. So let me just see if we bring me in there. There we go. All right. It's a little bit weird being a guy with a planetarium who can't actually use it because of all the things that are going on in the world right now. So it's a little bit strange, but we're going to make it work. I'm excited to just talk about space for the next 30, 45 minutes, maybe 60 minutes. I've got a bunch of stuff prepared about what's going on in the night sky tonight, so we're going to talk about that a little bit. And I'm going to make sure we open up the floor to lots of questions as well, because the real thing that I love doing in astronomy and planetariums is encouraging people to ask questions about anything to do with space, and then being able to show them answers to those questions live. So that's kind of the point of all this. I do have some things prepared because I want to kind of generate ideas and questions a little bit, but I'm going to do my best to answer all the questions that we get during the stream. I'm going to cut that for a sec. I just want to make sure we get the question up and running. Okay, there we go. So there should be a little questions thing where you can ask. You can type out any questions you want about what we're going to be seeing. Or anything really to do with space. I'm going to leave some time to answer those questions at the very end as well, to make sure that everybody gets a chance to ask some cool things. So without further ado, we're going to get started. There is one really interesting point I want to talk about, and that's that astronomy really connects us all. One of the cool things, I'm just going to switch back to me for a second so it's not just looking at the logo, but one of the amazing things about learning about the night sky is that whether I'm here in Canada or in Europe or in China, in Japan, anywhere in the world, at least in the Northern Hemisphere, we can all see the exact same sky. If you did go down to the Southern Hemisphere, the sky is a little bit different. But for us here in the Northern Hemisphere, we can talk about something that we see in the sky tonight, and within 12 hours, the people on the other side of the world will get to see those same amazing things. And so it's a really great way to kind of connect people and talk about space and do some fun things. So I'm going to do my best with this stream. It's like I said, it's my first time doing this kind of thing. So please feel free to leave me comments as we go along, answer some questions. And yeah, we'll have a lot of fun and keep going. So I'm going to get started with a couple of things about our night sky. And we're going to start with observing tools. And of course, the best observing tool you have is your eyes, right? When we look up into the sky, we can see things. You might say, well, I can see the moon. That's a pretty common one. You might be able to see the moon tonight after the sun sets. But there's lots of other things in the sky that we can see. We can see stars, we can see darkness, we can see lots and lots of fun things like planets in our night sky tonight. And so we're actually going to take a look at our night sky and see what's up there. So I'm going to bring us up to Stellarium right now. There we go. We can all see Stellarium. This is a free software that's really easy to use. It's if you go to stellarium.org, you can get it for free, and it's just a little program that allows you to go forward and backwards in time. This is what our western sky looks like right now, and you can already see there's a couple of labels up there. We have the moon visible and we have Venus visible. So we're going to scooch forward in time just a little bit and let the sun actually go down. It's going to set, well, it's set now, but it's really not going to get dark until, as you can see, about 8:15, 8:30. We see a couple of things whizzing by. We're going to talk about what those are pretty soon. But I wanted to stop here. This is at 8:20 this evening from here in Toronto. I know if you're tuning in elsewhere in Ontario, we're going to see some different things over time. But this is what you can see from here in Toronto at 8:21 p.m. And we've already got a couple of really interesting things up in the sky. We've got the bright planet Venus, and we've got the moon. Both bright tonight. We're going to take a closer look at the moon pretty soon, but I wanted to talk about Venus a little bit. It is a bright planet. It's the only thing that is brighter than Venus in the sky is the sun and the moon. So Venus is one of the brightest objects in the night sky. It's really easy to spot. You can see it a few hours after sunset at this point in the west. And so it's a really great one to take a look at. And one of the neat things about Venus is that it's so bright, yet it's not even full. And if we zoom all the way in to Venus, you can see that it is in fact a crescent. If we have a giant telescope to look a little bit closer at Venus, it is barely a crescent. But Venus is really bright for a couple of main reasons. The first reason being that Venus is really, really close to the Earth compared to other planets and the Sun. And the second reason is that it's got these thick clouds that are made of carbon dioxide. So they're really, really thick clouds that actually reflect light really, really well. In astronomy, we call this albedo. That's the reflectivity of an object. And so Venus has this really, really high albedo. It reflects lots of the light that comes in off of the sun and bounces it back. And a lot of that light gets to Earth and makes Venus look really, really bright in the sky. So if we zoom back out, we can see it here. Now, one of the things that people ask me a lot is, how do we know which ones are the planets and which ones are the stars? And of course, right now it's really easy to tell when we're looking at Stellarium because we have labels up in the sky. But in real life, we don't have those big letters up in the sky to take a look at, so it can be a little bit tougher. But one of the best ways to look at planets and figure out that they're actually planets, other than being really, really bright, is that planets don't actually twinkle. Planets don't twinkle. That's your magic secret that you can always use to identify some of the planets in the sky. And so if we take a look at this bright star up here, this is called Capella, and we're just going to center on Capella, and we're going to zoom in quite a bit to take a much closer look at Capella. One of the things that you can notice when we get really close, even here in the software, is that it's kind of pulsing. It's actually blinking, twinkling, right? And so the reason is that stars are really, really far away and really bright. And so when we look at them through telescopes, really they just look like little dots up in the sky. And they flicker and move because the air in our atmosphere is moving between us and that star. But here's something interesting, is that if we actually turn off the atmosphere, we see a change. It's not twinkling anymore. It's not pulsating. It's not flickering. It's not doing anything. It's just a dot. And so the whole reason that stars twinkle is because of the air that's around the Earth, the air that we breathe, which is pretty important, right? But without that atmosphere, the star doesn't twinkle. Okay, and so stars twinkle because of the movement of air in the atmosphere. If we zoom all the way back out, we see all the stars twinkling, but the planets a little bit different, right? Venus won't actually twinkle. And the reason that planets don't twinkle is because they have size. They're bigger. If we zoom in on Venus and take an even closer look at planet Venus, of course, we saw that it is a planet. It's not just a dot that's really, really far away, that feels really far away. It actually is a thing. It actually is a whole place. So pretty amazing stuff. And so when air moves between us and the planet just ripples. It doesn't actually twinkle. All right, so let's pull that back out. All right. Well, let's just see if we, I don't know if we have any questions yet, but I'm going to take a look. Nobody yet, but that's okay. I'm happy to answer things as we go through the night about anything that we see or anything that we do. But I do have a couple of polls because I want to ask some fun things. I want to first ask, what is your favorite inner planet? So you'll see that pop up shortly. You can vote on your favorite inner planet. This is also going to infer a few things about some of the streams next week and the weeks after, about what we do, what people are really interested in, that kind of thing. Okay, so there's our planet Venus. Now I'm going to show you a couple of resources that are really good to use when you're actually looking at the night sky, and I'll come back to me, so again, you're not just looking at the random stuff up there. But a couple of good resources that you can use to tell if it's going to be clear, aside from the weather report, is there's actually a really good astronomer's forecast that you can use. It's called Clear Dark Sky. All right, so we're going to go up to Clear Dark Sky. Oh, this is it here. So it's called the Clear Sky Chart. If you go to cleardarksky.com, you can actually find this. This is Toronto's version. There's different versions for communities all across Canada and around the world. And this is just kind of a weird looking thing, but it's a really easy way to tell what the sky is going to look like, what the night sky is going to look like, and how clear it's going to be. Basically, you can see in the green lettering right where the mouse is hovering that it's, again, Friday, and the time's 7 o'clock. We can see these little bars that have different colors and tell us different things: cloud cover, transparency, seeing. Those are the three important ones: cloud cover, transparency, and seeing. And then we get the red lines represent midnight each day. So you can see all of today and tonight, all of tomorrow. It looks like it's going to be really cloudy, and then Sunday, same kind of thing. So how to read this, though? The first row, I should say, cloud cover, is the most important one, because if there's clouds, it's kind of hard to see stars. And so we'll say that, oh, we're having some trouble getting the Q&A working. So I'll tell you what, let me try and bring that back up. Let's see if we can open that up. I'll come back to this clear sky chart in just a quick second. All right, do we see the question thing on the screen at all? I haven't actually used Facebook Live before, so it's a little bit new to me. I'm going to decide whether I'm going to use this or possibly like a YouTube stream, something like that. So I did just bring the question up. I've got a little thing in the top corner that you might be able to click on and ask a question, or you can even just type it in the comments, because I can see the comments pretty actively, so feel free to ask any questions there, and I'll answer them if you can't get the Q&A thing. So I'll tell you what, I'm actually going to close the Q&A thing, and you can just type your questions in the comments on the side there, and I'm going to open up that poll on our favorite inner planet. We've got some votes already, which is really nice. I'm going to reveal those polls a little bit later on, so we can get some ideas. But so thanks for participating in those already. And like I said, if you have any questions, just to answer, write them in the comments, and I'll get those right away, and we'll get to them. So back to the clear sky chart, we can see I was talking about cloud cover. Darker is better. Yeah, darker is better. Oh, okay. Yeah, better to put the questions in comments. Okay. So darker is better. Right now, it's clear outside. I don't know if you've been outside recently. Hopefully not. Hopefully we're all staying home. But there's not much cloud cover out there right now. The skies were beautiful today. Transparency is literally what it sounds like. It's how transparent the air is, how see-through the air is. And when there's a lot of moisture in the air, when it's really, really damp, we get to see a lot less of stars. And seeing is kind of how much the air is moving in the atmosphere, how much turbulence is going on. Of course, I can explain this for an hour, but I'm not going to do that. You can actually look just below, and it shows all of the info you need, how to read it, and what it all means. Okay, so that can help you out. So that's your forecast. We've got, oh, Jen, I love you. That Lucas wants to know about the moon. Well, I've got news for you. We're going to talk about the moon. I got some good stuff to show you about the moon pretty soon. So I'm glad we can talk about that. So that's our first one, the clear sky chart. I want to actually bring up a way to measure things in the sky, because I said that the first thing we need to look at things in the sky is our brain. But there are some other things too, and this is a really important one that I try to teach everybody, and not just kids, not just adults, just whoever wants to learn about it. These are going to be really important later when we talk about the Big and the Little Dipper, but this is a good way to measure things in the sky. So the idea is, what you do is you stretch your arm all the way out, and I usually like to start with a thumbs up, because that's the better way to do this. So I'm going to pull the me for a sec. I'll teach you these, and then I'll put up the image again. So here's me. I usually like to start with a thumbs up, except you want to stretch your arm all the way up, stretch it all the way up as if you're looking at the sky, as if you're covering up something in the sky with just your thumb. And so you start with your thumb. And if you want to measure something on the sky, 1 degree is your pinky finger. So you hold up your pinky finger up to the sky, and that will block out 1 degree. If you go all the way around the horizon, that's 360 degrees. And if you go from horizon up to the top point, which is called the zenith, that's 90 degrees. So you can get a sense of how much space is out there, right? So your pinky finger is 1 degree, which is about twice as wide as the moon. So when you see the moon outside, you can put up your finger and it will cover up the moon completely. Shows the moon is about half a degree wide. The next one we're going to do for all of you scouts and guiders out there, it's your pledge, right? Is the 3 fingers, your index, ring, and middle finger. 3 fingers on the sky is 5 degrees. That's 5 degrees on the sky. If we make a fist, knuckle to knuckle, or I guess this way, knuckle to knuckle, is 10 degrees on the sky. You can measure that again at arm's length. Then if we're going to a rock concert, we do this one. That's 15 degrees on the sky. And the most important one for me, I'm going to show you a little bit later on, is 25 degrees. That's from your thumb to your pinky finger when you're really stretching it out like you're making a telephone shape. Right? So if you have an incoming call, that's a good one too. All right, and that'll help you out. And you can see them all here. Just remember that they're all made for your outstretched arms. So when you're looking at stars in the sky, you can measure the distances between stars. You can measure the distance from a star to the moon, that kind of thing. So I'm going to leave this up for a second. I do have a question in the comments from Becky. Thanks for coming, Becky, by the way. It's nice to have you here. I was wondering if the level of atmospheric pollution affects how many stars you can see. I know light pollution changes things, but what about particulates in the atmosphere? Absolutely. One of the things I like to talk about with this is that when you see the moon very low in the horizon, if you live in a city, the moon looks a lot more colorful. It looks a little bit more reddish. And that's because all the particles of pollution and dust and whatever else is in the atmosphere is scattering light from the moon all over the place. Mostly the blue and the green and the indigo light that's coming off of the moon. And so that red light goes straight through and we get a little bit more red. I got to get a little bit better about transitioning to me when I'm answering a question, right? So light pollution absolutely changes things. Light pollution is things like houses and cars and streetlights and skyscrapers and all these things that shine up into the sky and block out stars. But actual pollution does that too. And when we looked at our clear sky chart, that actual pollution particles would affect things like the seeing. It would affect the transparency. So things that allow us to see clearer stars, better looking planets, using telescopes. Pollution itself is really bad. Smog is really bad. So thanks for that question. All right, we go back to our fingers there for a second. So we're gonna use this a little bit later as well. Thanks a lot for the question, Becky. That's wonderful. Now we're actually going to take a look at our moon. We're going to go back to Stellarium here, so we can take a look. There's Stellarium. And I just have to find Stellarium so we can bring it back up for me. There we go. All right, so we can take a look at the moon, and we're going to zoom in a little bit on the moon. Lucas, I know you're watching this one. I want you to take a close look at the moon, my young friend. We're going to go outside tonight and see that it is just the thinnest crescent. We are just past what we call the new moon. The moon's only about 4 or 5 days old. And it's not an actual new moon. It's the same moon that we always see in the sky. So don't worry about it. The moon's not disappearing and reappearing every month, but our ancestors thought it was, and so they called it a new moon when it reappeared a few days after it got close to the sun. So when we look at the moon in the sky, we can see just this thin little crescent. It's called a waning crescent moon, right? Or waxing crescent. Sorry, I always get those wrong. It's hard to remember all the phases, but waxing crescent. And the cool thing is that if we look at tomorrow, you can see that the moon is a little bit brighter. And if we go to Sunday, it's a little bit brighter. And we go to Monday, it's a little bit brighter. And so as the moon slowly works its way all the way around the Earth, we see a little bit more or a little bit less of it. And so this is, that was, I think, yesterday. There we go. And so today, the moon actually takes 29 and a half days to go all the way around the Earth, which is kind of why we have a month in the first place. All right, why we have a month in the first place. But you'll notice that as we skip forward or backward in time, we're still seeing the exact same face of the moon. This is this weird thing that we call tidal locking. Tidal locking. It's a really strange term, right? But tidal locking is an important term. We're actually going to take a look at our tidal locking. Here it is. Here's our tidal locking animation. Earth has a lot of gravity. It's a planet. It's big. It pulls on things. And so the moon is one of those things that it pulls on. The moon is relatively close to the Earth. It's 384,000 kilometers away, which sounds really far. But for a big moon, like our moon, about 3,500 kilometers across, the Earth pulls on it really, really tight. And so what that means is that the same face of the moon, the same side of the moon, the happy face in this image, is always pointed toward the Earth. The moon is spinning. It's just it takes the same amount of time to spin as it does to orbit the Earth. And so we always see the same face of the moon. You'll hear some people occasionally call the far side the dark side of the moon. And we just call it that because we can't actually see it in the sky, right? It's just never shown to the Earth. In fact, the first time anybody ever saw the dark side of the moon was when Russia sent probes in the 1960s to go and orbit the moon. And then, of course, the astronauts of the Apollo missions, when they did go to the moon in the late 60s and early 70s, they got to see the far side of the moon too. But today, we have maps of the entire 360 degrees of the moon, and you'll actually be able to see that the dark side, it's not always dark, right? We do have one more image on moon phases. So we're just going to transition out for a quick second. There we go. Here's our moon phases. So we can see that, again, we're seeing the same face of the moon all the time. But as the moon makes its way around the Earth, its angle changes a little bit between us and the moon and the sun, and we see less of it. But there it is, same face of the moon, the bright side of the moon. It does seem to wobble or rotate a little bit, and it does, because the Earth is pulling on it pretty tightly. All right, so let's take a look at our poll right now. I'm going to go back to here. I'm just going to take a look at our poll. Let's actually take a look at the answer. We've got some answers. We have some pretty... I think we have a winner, a clear winner. Mars is the favorite planet of those viewing right now, so thanks for voting. Earth, a close second. I honestly thought the Earth would be the winner in this one. I really, really did. And the reason for that is that, we live on the Earth. It's got the most air. It's got food that we can eat, water we can drink, air we can breathe, all those good things. And so it is... but Mars is pretty popular, right? Mars may have life. And so I'll make sure that we talk about Mars in a future stream, because that'll just be really fun. Mars is a really fascinating place to talk about as well. So we're gonna close our first poll, and we're gonna start with our next poll, and you can probably guess what it's going to be. Since we already talked about the inner planets, we're going to take a look and see what is your favorite outer planet. See if you have a favorite one there. Monica with a question in the comments. Am I crazy, or since I live in the southern hemisphere, is the man in the moon face upside down to me? And you're right, it absolutely is. Monica, who's in Australia right now, the moon does actually look upside down, because compared to us Canadians up here, you actually are standing upside down. And to you, who you think you're standing right side up, to us, we're all upside down. I actually wrote a blog post about it a long time ago, so I'll see if I can link that in the comments as well, and we'll take a look at that. So. But yeah, there is a big kind of explanation as to why that happens, and it really just depends on where you are on the Earth. So, so thanks for that, Monica. Okay, what's our next thing to talk about? Well, I want to talk about another observing tool. So we're going to come back to me, of course. Here we are. There we go. Our next observing tool, your binoculars. The way I used to tell this to people is that everybody's grandparents has a pair of binoculars somewhere. I don't know why everybody's grandparents has a pair of binoculars, but they all do, and they're just sitting there collecting dust. I think it was maybe a bird watching thing a while back, but if you have that pair of binoculars sitting at home or sitting at your grandparents' house, or whoever has a pair kicking around, grab it. This is a fantastic tool for astronomy that you can get at home. It costs a lot less than a telescope, and chances are you already have a pair kicking around. The great thing about them is that they also have it's like two telescopes side by side. So instead of worrying about, closing one eye and looking through a telescope, you actually get a nice straight up view of whatever you're looking at. And binoculars can actually see a lot of things in the night sky, not just the moon, not just the planets, but a couple of other objects too that we're going to talk about pretty soon. When you're selecting binoculars, usually there's two numbers. They'll be just on the between the eyepieces. These ones are 8 by 40. 8 is your magnification, and 40 is the size of your aperture. The size of each of these apertures, 40 millimeters. Okay, and so you can actually try them out. There's two little knobs, one on the top for adjusting focus, and one in usually the right eye. So the way to actually get them to work properly is you look at something, usually in the daytime it's a little bit easier, or in your house or apartment wherever you live. Look at what you're looking at, focus the top knob first to get it in focus, and then once it's in focus, make sure when it's in focus on your left eye, you can then focus the right eye to match, and it looks pretty good. All right, so you take a look at that. So binoculars, great tool. And it doesn't matter how big they are, how small they are, they're a really good way to start looking at things up in space. Okay. All right, we got another question in the comments from Chris Minahan. What causes the moon to always be facing the Earth? Magnetism? This is from Sophie in San Diego. Wow, thanks for tuning in from this far away. I'm really glad to have you here. So it's not actually the magnetism at all. There is the Earth is a magnet, the moon not so much these days. In order to have a magnetic field, to become a magnet, you need moving metal inside things like the moon. So I'm going to show you, this is why we always see the moon facing the Earth. This is our tidal locking that we were talking about a little bit earlier. It's actually gravity. It's really gravity that holds the moon tightly. And there's planets that are tidally locked too. In fact, a lot of the planets that we start to discover around other stars, they're tidally locked as well because they're so close to their star. The star is just hanging on for dear life. Right? There's so much gravity. It's pulling on one side of that planet and holding it. And so as it orbits, that same face is always pointed toward us. So that's kind of why we see the same face. I hopefully that helps Sophie there. But if you need any clarification on that, please feel free to ask a little bit more. All right. So that's our moon. So we talked about binoculars, and now we're actually going to take a look at some other stuff that you can see in the sky. This is something that everybody can take a look at in the sky. We're going to bring it over. It is the International Space Station. I don't know if anybody's ever seen the ISS before. I know some people have, but we're gonna bring over. This is called NASA's Spot the Station. It's spotthestation.nasa.gov, and I'm going to post it as a comment here so that anybody can go and take a look at this. So you can go find the Spot the Station website and kind of play along a little bit. I've done the sighting opportunities for Toronto, so I'm actually just going to go back to the main Spot the Station site, and this is what you see when it pops up, and you can literally enter wherever you live. So I'm of course entering Toronto. There you go. And I did that wrong, so I'm going to do it again. Oh, I think it just shows on the map. So I have to click this. There you go. View sighting opportunities, and it shows where we're going to see the ISS for the past 2 weeks and for the next 2 weeks. I mean, it doesn't really help to see it a couple of days ago. But for Friday, March 27th, we can see 8:19 p.m., which shows how long it's visible for, 4 minutes. How high up in the sky it's going to get, that's 21 degrees. Remember, that's about almost from your thumb to your pinky, right? Almost from your thumb to your pinky. Above the horizon, and where it's going to appear. And so we're actually going to take a look at this. Friday, March 27th, 8:19 p.m. for 4 minutes above northwest. All right, let's do it. Let's go back to Stellarium, which is going to help us see that. Of course, Stellarium, we're still taking a look at the moon. We're going to pull back from the moon a little bit, all the way back here, and let's see. What time did we say? We said 8:19 p.m. So we're a little bit far forward in time right now. So you can see the time right here. We're going to go back to 8, oh, close. 14, 15, 16, 17, 18. Ah, and here it is. You can just see it popping up right there. I'm going to go one time skip faster. We're going about 5 seconds for every second of real time. And this is it. This is the International Space Station. You can see its magnitude, minus 2.6. That's not as bright as the planet Venus, but definitely brighter than any star in the sky. All right, that is a really bright object. You can see how high it's getting. This is actually going to happen tonight, right? This is happening right, hopefully, after the stream's done. I'll go out and take a look. Of course, if you're in Toronto, that's kind of where you'll see it. So you can see 8:21 right now. So you can go outside in about an hour and take a look and see it. It is brighter than so many things, really easy to spot. It moves really fast. Of course, it's moving fast, right? It's going at about 27,000 kilometers an hour. But the really crazy thing is that as it goes further down range, something really strange happens. Watch closely. We're going to see it in a sec. Here it goes. It's flying, it's flying, it's flying. Yeah, it's not doing... Oh, there it is. Okay, good. It disappears. It disappears. And it's not because it's going below the horizon or anything's getting in the way. It disappears because it's actually moving into the shadow of the Earth. So there are certain times where you can see the ISS for 5 or 6 minutes as it flies right over top of us. But the really crazy thing is that as bright as it is, it's so bright it literally just disappears halfway through the sky, which is a really, really strange thing and really awesome to see. right? Really, really awesome to see. Okay, so let's see. I thought I had a question, so I want to just take a look and see what we've asked here. I don't see anything. No, I thought I had a new question, but that's okay. We'll get to these kinds of things. Oh, somebody sent me a message. That's why. Okay, I knew there was a question here. So we're going to take a look. This question is, how many degrees does the moon turn in 24 hours? So that's 1 day. So we can do the math on this. This is a question from Lauren. So thank you for asking that question, Lauren. So how far does the moon, angular, how far does the moon turn in, how many degrees does the moon turn in 24 hours? Not very much, right? It takes 29.5 days to go all the way around the Earth. So let's say 30 days to go all 360 degrees around the sky, right? So 360 divided by 30 is 12. So every day, every 24 hours, the moon is going to go 12 degrees in the sky. All right, great question. Thank you for that. So that's some putting me on the spot with the math, though. I got to say, I'm impressed and very happy to be able to do that for you. Okay, so there's our ISS disappearing in the sky. That is going to happen tonight. It's also going to happen again a little bit later tonight, as you could see in the Spot the Station, right? So we go back to our Spot the Station. We can see it is going to happen at 9:56 p.m. as well. So if you did miss the 8:19 p.m. one, it's not going to be as it's not going to last as long because it's going to pass into the shadow a little bit sooner, the shadow of the Earth. Right? It's usually easiest to see the space station and all satellites not long after sunset. And if we actually take a look at Stellarium again for a second, if we go back a little bit and go kind of fast, you see all these things buzzing around? There goes the ISS. You see all those things buzzing around? Those are satellites. So if we look, we're going to go and watch, we'll go back in time. We'll see the reverse sunset, not a sunrise, reverse sunset. So if we go forward a little bit, slow it down, you're going to see a bunch of satellites whizzing by. See them all go? It's easier to see satellites just after sunset because they are reflecting light from the sun being at a really low angle. All right, and that's how we do it. And go see the ISS. So you can check the Spot the Station literally anytime and see kind of what's going up. I want to take a look at our poll. My God, we're at half an hour already. Holy smokes, time flies when you're having fun, right? Well, let's see how our poll is going. Our second poll about what is your favorite outer planet. Oh, interesting. Let's see some results here. I gotta say, I'm pretty impressed. I thought Saturn would be the winner, and sure enough, it is, with 5 votes. Jupiter coming in at a close second. Nobody likes poor Uranus. That's so sad. And you can say it however you want. It doesn't bother me. I've only heard that about 20 million times. But in a later episode, when we do talk about the planets, I'm going to tell you a story about Uranus that's going to make you want to have it as your favorite planet. It's going to be your favorite one. You're also never going to call it Uranus again, or the way you might say it. So we'll talk about that a little bit later. I don't want to tease too much right now, but it looks like Saturn is the favorite. So we're going to reopen it, and I'll let you do a little bit more voting on that one, and then we'll see how we go from there. Okay, now it's time to talk about some things that we can actually see in our night sky tonight. What else is up there? Well, we've got the Big Dipper and the Little Dipper. I'm going to swing back to Stellarium in a quick second, but in our sky, the Big Dipper and the Little Dipper are really nice to look at. So here we go, back on Stellarium, and I have to change one option in order for us to really take a good look at the Big Dipper and the Little Dipper. So here they are. This is daytime, and what I did was I added in these things called asterisms. Now, asterisms are different than constellations. Asterisms are shapes in the sky that we recognize, and they're often not part of a constellation. So you can see all these weird-looking shapes around the sky. These are not constellations. We could actually bring up the constellations, and I think I'll actually do that so you can see them. There's all the constellations. So you can see that the Big Dipper is an asterism that's part of this much bigger constellation. We're going to let it get dark so we can actually see all the stars and see everything. We're going to get rid of the constellations for now. There we go. Okay, so we have the Big Dipper. This is our Big Dipper. This is our Little Dipper. And the Big Dipper is pretty easy to spot in the sky. If we go a little bit darker, we see the stars come out. The stars in the Big Dipper are pretty bright. There's 7 stars. And this one in particular is a really important one. This is Messier. It's the second from the end. in the handle, and if you zoom in, you can actually see that it is in fact two stars. Alcor and Mizar is what we call a visible double star. These are two stars that actually orbit one another. They're gravitationally bound. Gravity pulls them together, and chances are they were actually born together as twins. Well, the really crazy thing is that in our sky, 2/3 of all stars are doubles or triples, which means there's 2 or 3 stars all orbiting one another. And in fact, if we look, Mizar here actually has a third star that's really, really close to it, spinning around it from really far away. So you can't really see it, even in a big telescope. You need actually a pretty big telescope in order to see that third star, but if you have good eyes or a pair of binoculars, you can actually see the 2 of them up in the sky, no problem. So if we zoom out a little bit, we can see our Big Dipper here. We go all the way around. And this is where we get our hand signals are going to come in a little bit and be important. Remember how I said you could measure different angles along the sky, right? We have all those different angles. We'll bring them back up here, right? And I said that the most important one was that 25-degree angle. And you can see in the image that it's kind of showing the width of the Big Dipper there. But the real important reason to use that 25 degrees is that you can actually use it to find north. Okay, so let's say you're outside, you're lost, your cell phone exploded, so you have no GPS. It's tragic, right? And if you take a look, I mean, we don't have these big letters down here. We don't have an N for north, right? We can only see stars. If it's a clear night sky, you're lost, you don't know where you're going. What you can do is find the Big Dipper. If you find the Big Dipper, you can look at the 2 stars at the very end right here. This is Dubhe and Merak? Yeah, right on. Okay. Dubhe and Merak, and you can measure along the line that they make all the way over to Polaris, the North Star. And believe it or not, it actually measures about 25 degrees. So if you make that telephone shape, right, if we go and make our telephone shape, right, it's off the hook, and you stretch your arm all the way out at arm's length, you can see between, oops, there we go, you can see between Dubhe and Polaris. That's actually the distance. So you can measure to the North Star, and believe it or not, the North Star always points due north. The reason is that as the Earth turns, which we're going to see, as the Earth turns, the North Star is directly above the North Pole. Directly above the North Pole. And so as the Earth spins, all the stars appear to move. It looks like everything moves around the North Star. And so the North Star always stays due north. Okay? It just seems to spin. So you can always trust the North Star to find north, and then you can use any mnemonic you want to figure out where the other degrees are, right? I always use never eat shredded wheat, but from a few small kids I've learned fun ones like never enter smelly washrooms, never eat soggy watermelon, and never enter Santa's workshop. Good life advice. I did see another question come in, so I'm just going to take a look at that. I think somebody sent it as a message, so I'm going to pull it up. Oh, right. So this is Adriana asks, what is the difference between a constellation and an asterism? The constellations, a long time ago, were stories that people made up in the sky. Or rather, things that they actually saw. They looked up and they saw all these different shapes, and these shapes all had names, and they gave them pictures. They imagined pictures. They told stories about them. They told stories about things like the Great Bear, the little, right, that's our Big Dipper's part of the tail of the Big Bear, the Little Lion. They told these stories because they didn't have television, they didn't have cell phones, but every night they had no cities, no electricity, no light pollution. They could look up and see the beautiful night sky the way that astronomers today can only dream of seeing it, far away from city lights. And so when we look at it here, we can see all the different constellations that the ancient Greeks saw. The amazing thing about the constellations is that different cultures all have their own. We can actually bring up a lot of them in Stellarium too. So let's take a look at Inuit ones for a nice Canadian feel. I hadn't planned on doing this, but this is a great thing to do, so thanks for the question. And so the constellations, you can see the Inuit had the Caribou. That's the Big Dipper that we call the Big Dipper. They had the Caribou. I confess I don't know many stories about the Inuit constellations, but I do need to learn some, I think. So that's a really fun one. you can play around with all of those. But we typically, in Western astronomy, we use follow the Greek constellations, mainly because it's a good way to divide up the sky. All right, and I think there's a way to do that, but I can't remember right now, so we're going to pass on that. But there's all the cool pictures. An asterism, the difference is that an asterism is a shape that we recognize today. So when you or I look up into the sky, we don't see a great bear. We don't see a little bear. We see a big spoon, right? That's why we call it the Big Dipper. People in Great Britain, they actually call it the plow. They see it as a plow that farmers use to turn the earth so they can plant their crops. So different cultures around the world see different things for asterisms, but the constellations are the Greek constellations. All right, thanks for that question. Getting a couple hellos from friends in here, which is really nice in the chat. All right, let's take a look at our poll. We're going to go back here and take a look and see how things are going. Bit of a reaction to our... Okay, I think we're going to finalize our favorite outer planet. Saturn, I think, wins just by 1 vote. That's okay. We're going to bring up the last poll, and this one is going to have to do with what's going on next week when I'm going to do another stream, and we're going to talk about the Earth a little bit more, the Earth and the Moon and the Sun. So this is a bit of a question for everybody, and it's a tough question. But when is the Earth closest to the Sun? When is the Earth closest to the Sun? So that's a tough one. But you take a look and answer as honestly as you possibly can, and we'll see what you come up with. All right, let's go back to Stellarium and take a look at some other things in the sky. We're going to get rid of our asterisms here for a quick sec. That'll make things look a little bit easier. Right now the time is 3 a.m. We don't really need to be up that late. I certainly don't want to be, but while we're here, we're going to go a little bit further forward in time, and we're actually going to go over to where the sun rises, because as you can see here, we have 3 planets very, very close together, rising before the sun: Saturn, Mars, and Jupiter, all super close together, and a free satellite right there. There you go. So Jupiter, Saturn, and Mars, 3 planets. You can actually see the distinct colors as well. Mars does look red because of its rusty red soil. Jupiter and Saturn, of course, much farther away, but they're all kind of lining up in the sky. And so this is a really nice pre-dawn thing to see, and I say pre-dawn because it's quite early. This is at 5:30 in the morning. They're going to continue rising for a couple hours before sunrise. So if you do happen to be up early, if you're not getting used to sleeping in while isolating at home right now, you can get up early before sunrise, maybe 6 a.m., and see the 3 planets close together. And they do move a little bit. If we go to tomorrow, you can see they've shifted positions a little bit the next day, and the next day, and the next day. Our ancestors, or rather the ancient Greeks, 3,000 years ago, they called planets wanderers. And their word for wanderers was actually planets. So that's where we get the word planets from. Okay, so they can see those. They would be able to see those planets as well. Jupiter, Saturn, and Mars have been known about since before the written word. People knew that these objects were up in the sky, moving around all over the place, and that they were different than the stars. All right. Well, we got a couple ideas for the poll in the comments. Now, I know you can probably look it up. I trust that everybody who's answering, honestly, is not looking up the answer. And so I trust that you're going to be truthful about it. I will give you the answer eventually if we haven't already figured it out. But we're going to go back to earlier in the night so we can see some of the things. Whoa, that's too fast. Way too fast, way too fast, way too fast. I got to be a little bit more careful and be nice to everybody and go nice and slow. There we go. That's a bit better. Okay. So aside from Venus and the Moon, we're going to stay at about 9 o'clock. I think that's a good time to do some observing. So we've got Venus, we've got the Moon. There's a few other things up in the sky, and I want to start with some constellations. I want to actually start with one of my favorite constellations. This is Orion the Hunter. Not just because its name sounds like my name, but it is up there in the sky, really bright. Unfortunately, Orion, because we're getting through winter and into spring, Orion is a winter constellation, and so every night it's going to get a little bit lower toward the horizon until it disappears completely for 6 months, and will come back in the fall to tell us that winter is coming. But Orion the Hunter, if you can go outside and see it, there's a few interesting things to take a look at. First of all, we have 2 very bright stars. In the bottom right side, we've got Rigel, which is a bright blue star, and on the upper left corner we have the bright red star called Betelgeuse. Now this one, aside from sounding like a cartoon character from the 80s, is a really fascinating star, and it was in the news a lot recently because it was dimming. Now that's really important because Betelgeuse is what we call a red supergiant star. It's a star that is close to the end of its life. It is going to explode someday. However, when I say someday, I mean it could explode tomorrow, and it could explode 1 million years from now. We don't know. But if it does explode as a supernova tomorrow, that would be really fantastic because it would be so bright that you could actually see it in the daytime. Which means not only do we have the sun in the sky, we would also have this bright star, Betelgeuse, in the sky for about 2 weeks. So the question is it going to explode anytime soon? Unfortunately, the answer is probably not. Betelgeuse did get a little bit dimmer a couple of months ago, but it's so big, it's actually boiling, like boiling water, bubbling and swirling, and that causes it to get brighter and dimmer. Because it did get brighter a couple months ago, it did get dimmer, and then it got brighter again, and now it's going dimmer again. So it's just, it's what we call a variable star. Okay. But in Orion, if you look, you can kind of see Orion the Hunter kind of looks like a person, looks like a hunter. Right? You can see, the funniest thing I like to tell people is that Betelgeuse is an ancient Arabic name that literally means the armpit of the Great One. And so Betelgeuse is literally the armpit of the hunter. A nice gross thing to think about right now. But there is the armpit of the hunter. And in Orion, if you see the belt, the sword of Orion has these really fascinating little objects in there. So we're going to take a closer look at those objects. We're going to get rid of the artwork there. Let's zoom right in, and you can see this is known as the Great Nebula in Orion. A nebula is a big clump of gas and dust that forms new stars. This is like a stellar nursery. This is a place where new stars are being born and have been for millions and millions and millions of years. Those new stars, when they're born, they glow in infrared, ultraviolet, visible light, and their light bounces off all that dust and gas in the cloud and causes it to glow. We can actually see this glow all the way from Earth. And one thing I want to point out is that if we zoom in on it a little bit, you see this little FOV here? That means field of view. So that means that this whole field of view from the left side of the screen to the right side is about 1.3 degrees, which means the Orion Nebula itself is about half a degree across. So when you're up in the sky, you can hold up your pinky finger, like we learned earlier, and that will give you 1 degree on the sky. So the Orion Nebula is about as wide as the full moon and about half the width of your pinky finger, which means it will look great in a pair of binoculars or a small telescope. And you can actually see it with just your eyes if you have really good eyes. All right, I want to answer a couple more questions because they've been popping in, which is really awesome. I've got a question from Daphne Campbell. So your question is, are there black holes in outer space? And the answer is yes, there are lots and lots and lots of black holes in outer space. In our Milky Way galaxy alone, we think that there's about 50 billion of them. Sorry, not 50 billion, I think it's 50 million. Either way, that's a lot of black holes. The problem is we can't see them because by definition a black hole doesn't give off its own light. So there are a couple of random rogue black holes all flying around out there. Now we don't have to worry about them very much. The space is so big that if a black hole did get relatively close to the solar system, chances are nothing bad would happen. It wouldn't get close enough to do anything. There are ways that we can see black holes, however. And the best way to do that is to look at the center of the Milky Way galaxy. The center of the galaxy isn't really visible right now. You can kind of see the Milky Way going across the screen right here. But it does, I wish I could probably brighten it up. I have to learn how to do that. But along the Milky Way, if we bring up deep sky objects, you can see there's a lot more of them kind of along the Milky Way galaxy. Well, in the center of the Milky Way, we're going to talk about a few of these guys too. In the center of the Milky Way, there is what's called a supermassive black hole. It weighs about 3 million times as much as the sun, and it's sucking up gas and dust so quickly that it glows, and that allows us to actually take a somewhat close look at it. So there are lots of black holes out there, so thanks for that question. A couple more in the chat. We've got a question from Jill. Hey, Jill. Let's see. I got just a little bit of your question, I think. Immediately, or would there be travel time for the light to be visible to human eyes on Earth? So you mean like the travel time for light from an object to be visible to human eyes? Things that are far away, If something is 1 light year away, it means it takes light from that object 1 year to reach the Earth. Okay, so we'll come back to that if you have some clarification. But we're going to take a look at Orion because, of course, we have the big Orion Nebula in there. There's one other lovely little object to come by over here, and Venus is actually quite close to it tonight. So just up from Venus, if you go from the horizon, directly above Venus is this little group of stars, and I probably selected the wrong one. No, we want the whole thing, please. There we go, that's better. This is known as the Pleiades. The Pleiades in mythology were 7 sisters. They were actually 7 princesses. And if you look closely, you can maybe count 7 very bright ones. I'm going to leave it here so you can see maybe 1, 2, 3, 4, 5, 6, and pick your 7th. A little bit tough. I only typically see 6 of them. But the Pleiades is actually called an open star cluster. It's a group of stars that were all born together in a place just like the Orion Nebula. Except when all those stars were born, they blew away the rest of the gas and dust. And so all that's left is these stars. Our sun was actually born in a star cluster as well. But over time, of course, the sun is 4.5 billion years old. It's had time to drift away from its birth cloud. So we're not really sure where those other stars are that were born with the sun, but there are some. Oh, Jill, the supernova you were talking about. Oh, okay, yes. So there are, it would take, Betelgeuse is, I think, about 300, I think it's 600 light years away. So if we go back to Betelgeuse, it should say the distance as well. I don't know if it will. Oh, there you go, 497 light years away. So it takes 497 years for the light from the supernova explosion to reach us. So when I say that it could explode tomorrow, that means it actually did explode 497 years short a day ago and has traveled, that light has traveled all the way to the Earth, and then we would see that explosion tomorrow. So let's hope that happens so we can take a good look at it. Okay. So this is our Pleiades, our 7 sisters. A really nice thing to see, very tough to see in the city. Not easy at all, but you can see it. If you have a pair of binoculars or just want to take a look with your eyes, it is visible to just your eyes. And if you get to some darker skies a little bit further away from the city, it looks really, really nice up there. Now there are a couple other objects I wanted to talk about. One of my favorites, though, and I'm going to show you some other stuff. You see this little fuzzy patch, right? No, it's not letting me select that fuzzy patch. Let's go in a bit closer. There we go. This is called Messier 31, the Andromeda Galaxy, and this is one of my favorite objects in the night sky. I actually did my master's research on M31, and Andromeda is another galaxy. It's like our Milky Way. It's a big spiral galaxy. It's up in the sky. You can see it with just your eyes, but especially in a city, you're going to need a telescope in order to spot it. But if you get outside of the city and have some binoculars or a small telescope, you can actually see it, and it looks really beautiful. And the reason I brought this up is that I want to show you one of my absolute favorite pictures in astronomy. Okay, I'm going to bring it up here. This is a picture of the Andromeda Galaxy that was taken by the Hubble Space Telescope. Okay, this is about, I think, 6 years old at this point. And so this picture is really amazing. I mean, it looks like any other picture. It's a galaxy, right? You can see just kind of the center of the galaxy over here in the bottom left corner and the outer spiral arms. Well, when we talk about galaxies, we're talking on the order of billions, hundreds of billions, even trillions of stars. The Andromeda Galaxy is known to have about 1 trillion stars in it. And I can say that, and it probably doesn't have much meaning. You might think, oh, that's a big number. There's probably a lot of stars in it. Well, this image from Hubble was the first chance that we ever had to see all those stars. And the reason I'm saying that is that if we zoom in a little bit, not only do you see the spiral arms and these brighter stars, which are actually within our own galaxy, within the Milky Way, but if we zoom right in, you can start to see every individual star that makes up this galaxy. Every single dot that you can see in this picture that I've zoomed in on is a star. Every one of these little dots. And all of these stars make up the Andromeda Galaxy. Trillions of them. It doesn't matter where we look in the galaxy. I'm going to look for the darkest spot. Okay, we're going to go over here to the darkest possible point. I think this is pretty dark. Let's go all the way in. And even in that darkest spot, still stars everywhere. And you may be saying, well, let's go take a look at the brightest spot too. Well, yeah, there's a lot more in there too. And so if we go in even closer to the center of the galaxy, you can see that there's so many stars They all overlap. There's no dark space. You can't see through it. There's so many of them. So when we say a galaxy has 1 trillion stars, this is what we're talking about. And this is all in the Andromeda galaxy right there, which is pretty fantastic. So let's... one more thing, actually, I want to show you about that is that the Milky Way and Andromeda are actually going to collide someday. You might have heard this before, that the Milky Way is going to collide with Andromeda. Andromeda is the only galaxy in the sky, the only large galaxy, I should say, that is actually moving toward the Earth. All the other galaxies in the entire universe are moving away from the Milky Way, right? And that's because the universe is expanding. And so I'm going to show you that the Milky Way and Andromeda are actually going to collide someday. Not for about 4.5 billion years, so I wouldn't worry too much about it. But I am going to show you what that collision looks like. This is actually content that I have in my planetarium. I just thought it's so good that pull. And they're going to continue to spiral together forever. Well, for a very long time anyway. And so this is, you can see stars are getting kicked out of the galaxies. And the question I always get is, what's going to happen to the sun? Is the sun going to be okay? Well, 4 billion years from now, we might not be here to see this collision. But the sun will probably be fine. Because galaxies are so big, they have so much empty space, it's very unlikely stars will ever collide. The only bad thing that could happen is if another star came into our solar system and tore away all the planets away from our solar system, and then we would all end up in outer space and we would probably freeze, which wouldn't be very good. But again, 4 billion years from now, we don't need to worry about that too much. Okay, so let's come back to Andromeda and Stellarium. And we'll come back here. So we've been going for about an hour, which is pretty crazy to me. I don't feel like I've been talking for an entire hour, but I think this is a good a time as any to just about call it. I am going to answer some more questions first, I think, and we're going to check in with our poll, actually, because I've been wanting to do that. Oh, around some. Let's see. So we're going to bring up our poll. Oh, look at this. Nice. Show results. There we go. Okay. Sorry, I'm just having a little bit of video issues there. There we go. So let's take a look at our poll. Oh my gosh, you are very good. It's pretty common to think that the Earth would be closest to the Sun in summer, but the answer is actually January. The Earth is closest to the Sun on January 3rd. Which is pretty crazy to think about, right? You would think that, oh, it's, summertime. The Earth obviously has to be closer. It's getting more sunlight. But that's not why we have seasons, right? The reason we have seasons is because of the tilt of the Earth. And that's something that I think we're going to talk about next week. The next episode is going to be on the Earth, the Moon, and the Sun. So I think I'm going to stream that on Tuesday at 7 p.m., here in Eastern time, so I'll post all that stuff so we can take a look at it. I did have a couple other questions. I had a second question from Daphne. Wow, you're asking the serious questions here. Where is the center of the universe? Well, I have to tell you that's a really tough question to answer, but I'm going to do my best. The center of the universe is everywhere. Okay, and the reason has to do with light. Is that and I'll bring myself in here so I can actually kind of talk about this. You can see me umming and ahhing as I try and figure this out for you. But basically, when we look out into the sky, we look in all directions, and it takes light time to reach us from all those different directions. If you imagine a bunch of stars, some are closer, some are farther, it takes light different amounts of time to reach us. And so there's a star that's 10 light years away. It takes 10 years for the light from that star to go from that star all the way to the Earth. Okay, and so it's like we're looking at that star as it looked 10 years ago. It's kind of a tough thing to wrap your head around, but basically just understand that it takes 10 years for that light to reach us. Now imagine a star 1,000 light years away. Now it's 1,000 years for that light to reach us, and now we see it as it looked 1,000 years ago. For the Andromeda galaxy, that galaxy we looked at in Stellarium and in the simulation, That galaxy is 2.5 million light years away, which means it took 2.5 million years for light from that galaxy to reach us. And so when we look at it in the sky, we're seeing it as it looked 2.5 million years ago. Now get this, the universe is 13.8 billion years old. So what that means is that there is an age limit. If we look further and further and further and further away, there's a point where we just can't see anything anymore. There are things out there, the universe is big, but the light from those objects hasn't had a chance to reach us yet. And so we can't actually see them. All right, and so what that means is that basically it's like we're living in a big sphere, a big ball, where the light from all those distant objects is reaching us all the time, but anything beyond that barrier of the beginning of the universe, we can't see. And so it's like we're in a big sphere, and where's the center of the sphere? Everywhere. Right? For us, it's on Earth. But if you go to Mars, you can see in every direction those objects that were shining from 13.8 billion years ago. And so basically, the center of the universe is everywhere. Now, that's a very deep question, and I thank you for asking it, because it's nice to do a deep dive once in a while, but I'm going to bring it back home. Let's bring this back up for a second. All right. Do we have any other questions? Oh, we have one more here. Okay, what is the galaxy expanding into? Maybe the universe. What's the universe expanding into? That's a tough question. Really, really tough to answer. But if we knew that, we might have an idea of where the universe came from, which would be really awesome if we knew that. There are some people who are working on that, but it's kind of, I kind of liken it to, imagine that your entire life you spent inside your house. Okay, we'll bring you back. Imagine that for your entire life you were just inside your house. Would you know that there were other houses out there? Well, maybe you could look out the window and potentially see them. But now let's say you were just in the basement, there's no windows, no nothing, and you're in this house. Would you be able to tell that there was anything outside your house? The house is the universe in this case, right? So you could potentially hear some truck going by. Maybe you hear something and you're like, oh, maybe there's something out there. You start to see signs of there might be something beyond our house, our basement. But until you actually can go and look out there or learn new ways to study what you're hearing, it's really hard to tell if there is anything outside of our universe. And what's it's expanding into? It's tough to tell because it's not like it's a bubble getting bigger and bigger in space. It is the expansion of space and time, for that matter. So that's a really great and very difficult question. Thank you for asking that one. All right, so I think that's about it. I'm going to just talk a little bit more next week's stream. I'm going to try and stream on Tuesday and Friday next week because I want to do this a little bit more. The reason that I do all this, it's not to push things, it's not to promote things, although I wouldn't have a problem if you wanted to book me for a planetarium show in a few months, right? I'm doing this because I love talking to people about space, and I really wish that you and I could be face-to-face right now, but unfortunately we can't, so this is the best that we can do. So thank you for tuning in. I'm really excited to have everybody here. I think at one point we had about 50 people viewing the stream, which was really wonderful, and I hope that next time we knock that out of the park so I can reach more of you lovely people. Last little things, I'm going to be uploading this to YouTube once we're done, so if you wanted to see anything again, hear some of the answers to questions, check on any of the information so you can go outside and do some observing, you should be able to do that pretty soon. I'm going to try and upload it right now so it goes up, and that's about it. So thanks very much for tuning in, for checking it out. It was a real pleasure doing it, and I'll see you on Tuesday at 7 p.m. for the next one. All right, thanks for watching.